Welcome to part 2 of my 3-part video series on how to find the inverse of a function algebraically. In this video I'm going to go through 2 examples of how to figure out the inverse when you're given the function rule. Before you watch this video, you're probably going to want to watch the first video called What's an Inverse? It'll give you a general idea of what this whole idea of inverse means, and then after that you might want to watch the video where I sort of graph an inverse, and then of course before part 2 you're probably going to want to watch part 1. But here we go. We're starting with number 5 because in the first video we did 4 examples. So I guess I'll kind of go through this video as if you didn't see the first part. I'm going to go a little bit faster though, just so I don't bore the people who did. Our goal is to figure out what f inverse is, and that's the notation we're going to be using here, -1. Right? We never say f to the -1 power of x, we just say f inverse. In order to find the inverse, first thing I'm going to do is change f of x to y, and then I'm going to just switch x and y. I'm going to switch them. After I switch them, my goal is to get y by itself. So let's get the 2 over here. We'll subtract 2 from both sides. And next, let's get rid of this exponent of 5, right? Just like you would get rid of an exponent of 2 by taking the square root. To get rid of an exponent of 5, you take the 5th root of both sides. And that sort of cancels out the exponent of 5, leaving you with just what's underneath or what's inside those parentheses. So we have the 5th root of x minus 2 is equal to y. We don't want to write y though. This is our inverse. That is our inverse right there. And to confirm that, to make sure that that is actually accurate, we have a couple different options. Alright, I'll go through both of these options for the first example, but not probably the second one. I'll go a little bit faster for those. So I'm going to bring this thing down here. And there are 2 options. The first option is to plug in a number. So let's plug in, I don't know, f of 1. Let's keep it simple. We plug in f of 1. We plug in 1 for x into our original function. We're going to get a value, a range value. 1 plus 2 is 3, 3 to the 5th. Alright, so 3 squared is 9, 3 squared is 9 times 3. So 81 times 3, 243. So this is 243 plus 2. Hopefully that's not incorrect. I'm doing that in my head. 245. So when x is 1, y is 245. So my claim is that if the function gives you 245 when x is 1, the inverse, when you plug in 245, you should get 1. So there's a nice sort of symmetry between those values, right? The function and its inverse sort of undo each other. So let's check that. All right, let's take this function right here, this inverse that we just found, and we'll evaluate it for 245. So we're finding, let me write it on this side. We're finding out what the inverse gives us when we plug in 245 for x. So it's the 5th root of 243. And we already said the 5th root of 243 is 3. 3 minus 2 is 1. So that works out. That's confirmed. The other way to do that is to work with composite functions. We're going to compose f with its inverse. When we do that, when you compose a function with its inverse, you always get the same thing. And the other way should be true as well. Remember, when we compose functions, the operation itself is not commutative, which means you can't just kind of reverse the order of these things normally, but for inverses it should hold true. The commutative property should hold true. So no matter what order you do your composite, you should get the same thing, and that thing should be x every single time. That's not just true of example 5, that should be true of every function and its inverse. So let's check it. Let's check the first option. Move that over there for a second. So let's compose f with f inverse. So I'm going to rewrite f, but instead of x, I'm going to put the inverse. And the inverse was this. Plus 2. Well, I'm kind of getting a little bit backed up here. So let me clarify here. What I'm doing is I'm replacing x with its inverse. So this right here is the inverse. But we also have another plus 2 right here, and then that's raised to the 5th. So I rewrote this entire function, the original, but instead of x I put in this little substitution here. That's how we compose functions. So let me erase that now and we'll simplify. So let me kind of clean some of this up on the inside here. Negative 2 and 2 is 0. Let's clean it up a little bit more. 2 plus, now the 5th root of something to the 5th. The 5th root to the 5th. The 5th root to the 5th. They cancel out, just like when we had the square root of x to the 2nd power, right? That was essentially like saying the square root of x times the square root of x, which is just x. In other words, square root to the 2nd power, they sort of undo each other. They're inverse operations. Similarly, the 5th root of x minus 2 to the 5th power is just x minus 2. And what do you know? When you simplify that, the 2 and the negative 2 cancel out, and you're just left with x, which is what we wanted. That tells us that indeed f and its inverse are correct. Let's confirm it the other way. Let's do the composite, or the composing the other way. Let me give myself some space here. So I'm going to rewrite the inverse, and instead of putting x in there, I'm going to put the function, the original function, which was, I'm getting mixed up now, 2 plus, there it is, 2 plus quantity x plus 2 to the 5th. 2 plus quantity x plus 2 to the 5th. And so what I'm doing right now is I'm rewriting the inverse, which is right here in yellow. But instead of the x, instead of that x value, I'm going to put in the function which is right above. Alright, so it's the 5th root of 2 plus quantity x plus 2 to the 5th minus 2, and then minus 2 on the outside. A little bit confusing, but hopefully you're on track here. X plus 2 to the 5th minus 2 underneath, minus 2 on the outside. This is what we get when we compose in this order. Let me make sure I didn't mess up there. A lot to think about here. So I rewrote my inverse, but instead of the x, I'm replacing it with the function. Yeah, I think I'm good. So my claim is that this should yield for me just the value of x. So let's clean this up on the inside first. 2 minus 2 is 0, so this is just x plus 2 quantity to the 5th, and there's a minus 2 on the outside. Let's clean it up a little bit more. Again, the square, or the 5th root of something to the 5th is just itself. So x plus 2 minus 2, yeah, that's just x. So that works out. We confirmed it both ways. We confirmed it this way, and we confirmed it this way. And algebraically, it turns out that both of those are the same thing. So that's a good result. That means that when we calculated our inverse in yellow right here, we did it correctly. Number 6. Replace the f of x with y. Replace the x with y. And solve for y. So again, we have a proportion. So we just kind of cross multiply and we get y is equal to negative 4 over x minus 2. As a shortcut, when your variable that you're looking for is in the denominator, just kind of switch it out with the thing over here. It's a little shortcut rule. Really, it's just proportion cross multiplication. So our function y is by itself, that is our inverse, and that's equal to negative 4 over x minus 2. Now you might, if you're doing this exercise in a textbook or something, you might see that written as negative and then this, or you might see it written as positive 4 over negative x plus 2, where that negative kind of goes into the denominator. A lot of my students sort of struggle sometimes when I give them exercises from the back of their book or in their textbooks, and they look in the back for the answers, and their answer doesn't look exactly like what they actually got or what the textbook says. So, just be careful. A lot of times, if you got something like this and the textbook says this is the answer, well, you're right. You got it right. You just, didn't happen to write it the way that they wrote it, which is fine. So that is my inverse of my function, right? And you can, again, go through those algebraic steps to confirm. You can also, confirm graphically. When you graph a function with its inverse, you should get that they are symmetrical across this line. Graphically, that's what they look like. There's a symmetry across that line, y equals x. And I'll let you do that on your own, but hopefully you got a lot out of these two examples, right? Some of them are a little bit more complicated than we saw in video number 1. But in the next part will be part 3. We'll take a look at a few more of these where I give you a function, ask you for an inverse. And I'm also going to give you 2 functions and ask you if they are inverses. So look forward to that. But anyway, thanks for watching, and make sure you subscribe so you don't miss any videos.